All right, welcome back to Rules of Exponents, guided notes. Again, you should have these notes that I have already given to you, hopefully. If not, remind me to give them to you. I cannot take credit for this. This was from Elizabeth Kessel, or whatever her name is. Thanks, Elizabeth. So let's get started. This is more practice of the rules that we talked about in the last video. So here's some vocabulary. Monomial, which we will get into in our next section, is just talking about a number, a variable, or a product of a number and one or more variables. So kind of like an expression right here. And then a base, hopefully you already know, is the big part. And the exponent is the one that's telling us how many times to multiply that base. All right, let's look at product of power rules a little bit more as we did the other day. I would encourage you to pause the video here. Go ahead and do these since we did do an introduction on how to do them in the last video, and then you can press play and see how fantastic you did. All right, so remember this says as long as the bases are the same, then we can just add the exponents. So since these bases are both 5, then I can just add their exponents. 2 and 6 are the exponents. So that will give me 5 to the 8th power. And that's good. I don't need to write out whatever long number that is. So same thing here. Remember, there's a 1 there. So we are going to do y to the 4th plus 3 plus 1, adding up all the exponents that have the same base. So we have y to the 8th. The next one. So our like terms, 7 times 6. The parentheses there don't interfere with that. Times y to the 5th. And then this y has a 1 there, so plus 1. So 7 times 6 is 42. And y to the 6th, using the product rule. All right, this one has a little bit more going on, but it's not too hard. -3 times 5. Then we have times x to the 2nd. And then we have an x to the 1st right here. So plus 1. And y times y to the 7th plus y to the 6th. So simplify that. -3 times 5 is -15. And x to the 3rd, 2 plus 1, times y to the, is that 13? Hopefully you can see that. It's kind of messy. 13, that's a 13. All right, so that's a quick review of product rule. Now let's try quotient rule. Remember that says as long as the bases are the same, then we can subtract from top to bottom. So this has a exponent of 1 anytime there's not anything there. So we're doing y to the 6th minus y to the 1st, which simplifies to y to the 5th. Hopefully you're starting to get a hang of these now. We're going to subtract from top to bottom. So the 13th power minus the 2nd power is 6 to the 11th power, whatever giant number that may be. See if you can do that one in your head. All right, 10 over 15. Pardon my funky writing. And then we have a to the 7th and a to the 5th. And b to the 9th over b to the 9th. So remember, we are subtracting here whenever we're dividing. So 10 over 5, let's see, that simplifies to 2 over 3. 10 divided by 5 is 2. And 15 divided by 5 is 3. And 7 minus 5, I know I'm going to go ahead and write it out just so you can see the steps. And b to the 9 minus 9. So 7 minus 5, what is that, 3? No, 2. It's getting late, guys, so my brain is getting slower. 9 minus 9 is, of course, b to the power of 0. And this is 2/3. So remember, this turns into a 1, so I don't need it. So my final answer, squeeze it down here, 2/3 a squared, and that's it. B goes away because it's just multiplying it times 1. All right, let's go on to 0 exponent. I said in the last video we would talk about why. Well, here's why. We're using our quotient rule, which says if the bases are the same, then we're just going to subtract, which we saw on the last problem with our b. So we would do 8 to the second power minus the second power, and that's 8 to the 0 power, which is 1. So in this example, I love anything to the 0 power because it makes it real easy. All of this is in parentheses, so it's just going to equal 1. All of this to the power of 0 is 1. And this one, notice that there's no parentheses, and the 0 is the exponent on our x variable. So this is really saying 8 times x to the power of 0 plus 5. Well, that's 1, so we would have 8 times 1, where x to the power of 0 used to be. 8 times 1 is, of course, 8, plus 5, and so our answer simplifies to 13. Ta-da! All right, let's see what's next. Negatives. We don't like to be negative, so let's see how we can fix it. We need to do the reciprocal. And I say reciprocal because sometimes the negative exponent will be in the denominator, therefore we need to put it in the numerator. So this is trying to just explain to you by writing it out. B squared, of course, means b times b. And b to the 5th means b times b times b times b times b. Aren't you so thankful for exponents? Because that would be exhausting writing that out. And these cancel because that becomes 1. Any number or any variable divided by itself is 1. And this becomes 1. So what's left here is 3 b's in the denominator. Like that. So let's look at this one. All we're going to do here is this is basically 2 over 1, and then it's got a negative exponent. So we're just going to flip that. The reciprocal is 1/2 with an exponent of positive 3 now. So we made our exponent positive. So same thing here. We are going to flip that. Now notice the negative 3 is in parentheses. The negative here was just referring to the exponent, not our base number. Here, the negative, there is a negative that's referring to our base number. So don't get confused with that. So we're still going to do the reciprocal or flip. So it's still negative 3. All that changes is the exponent is now a positive 3. All right, I think that's it on that page. Let's go on to the next. Power of power rule. So this was the one that we didn't get to really. So it's just saying if we have something on the inside of the parentheses, then it's actually raised to that power. And you'll know because there's the parentheses there. So this is saying x squared times, that's times the 8th power.